Alright, so now we're going to start questions on homework.
Yes. Yeah, I was going to ask that. Hold on,
X. What's 22?
X, 2 power 3, 2 over 3.
X to the power 2/3.
Yeah. Plus 1 2/3.
Y to the 1/3.
2/3. Equals 40. And the points are on, there are X and Y points.
Okay.
So negative 3 radical 3, comma 1.
Oh, negative 3 radical 3,
Yeah.
comma 1.
Yeah.
What was the question? Find the
Find the tangent line and the equation. Find the equation.
Find the equation of the tangent line at that point. Okay, so how do we do it?
Find the derivative.
Find the derivative, dy dx in particular.
Yeah.
Right, so
2/3 X.
2/3 x to the
1 plus 2/3 y negative 1/3 dy dx.
right, dy dx.
Equals 0.
So we can actually divide 2/3 on both sides, so we get dy dx is actually minus x to the 1/3 over y to the 1/3. With just y to the 1/3 over x to the 1/3. So now we just plug in the points.
Now question.
Yes.
How do you just get rid of the 2/3?
Divide both sides by 2/3. It's an equation.
Oh.
Yeah. Yeah, so now we plug in the points. So we know that m is equal to minus 1 over minus 3 radical 3 to the 1/3. That's minus 1 over. Inside here we have, well, now that would be plus, but that's minus. This is 3 to the 3 over 2, so 1 over 3. 1 over radical 3. Y minus 1 equals this. Questions?
Can you like somehow like maybe into another form of the equation, like the y equals 1?
Sure, we could do that. So this is y equals, if you distribute here, this is 1/3. Here, the radical 3's would cancel, so you just have plus 3. And then this minus 1 can be equal to plus 1. So we'll do that. Or not.
I don't get for finding the slope, I don't get how you got to the second step.
Right, do you understand that I plugged into this equation?
Yeah.
Right, so I know my y was 1, so I just replace 1 here, that's just 1 to the 1/3 is still 1. And here I plugged into x. Now I recall that 3 to the radical 3 is just 3 to the 1 times 3 to the half, which is 3 to the 0 over 2 by the law of exponents. So I replace this in here with 3 to the 0 over 2, 1/3 still out here. It's an odd radical, so which means the minus sign stays, cancels that minus sign, so it'll ends up a plus. And then now I multiply the powers, the 3's cancel, I just get 3 to the half, which is radical.
My camera is so cute.
Any other questions? Any questions on this? 12?
Radical x plus y.
But I'm not doing it now.
X plus y is radical.
Under the radical of x plus y,
Equal to 1 plus x squared y squared.
1 plus x squared y squared. And what was the question?
Find the derivative.
Just find dy dx. Alright, so I can think of this as x plus y.
Or you can just start by so 1 over 2.
So now I have to do the chain rule. I have to differentiate the outside function.
1/2x plus y, negative 1/2.
Multiply the inside, which is
1 plus y
1 plus y prime. Right.
equals 2x y
All
squared.
right. Derivative 1, 0 here
2x y squared. X squared y prime.
plus squared.
2y y prime.
Right. So now I want to isolate y prime. So first thing I'm going to do, I'm going to break this one out of jail. Distribute this times 1 itself, this times that, I get.
There's a easy way to do it.
Huh?
There's an easy way to do it that they showed it on the test.
What way do you want to show?
Well, since they changed the 1/2 x plus y to negative half as a fraction, so you just put 1 plus y prime over that.
Yeah, and
And then you multiply both sides by the bottom part, which is simpler than
it's more easy to visualize it that way. Like, look like this.
But you have a y prime over here though.
Yeah, and you're gonna get it to the other side, move to the other side.
Yeah.
And then you show the radicals, because it's easier to visualize.
Let's see what I show that. If I multiply both sides by that, I'm gonna have to expand the brackets here to move that guy over anyway.
I don't know, but I find it easier to
Either
yeah.
one.
It was a suggestion.
They already see the difference. Okay, so your y prime. That's fine. Or you can multiply top and bottom by 2 if you don't like the halves here. And so this would be 4, and that would be 4. I mean, doing it the other way to me, it's the same thing, but psychologically it looks easier to you, do it that way. Other questions? 10? I guess it's the same thing as this one? Oh, what did it say?
y sine x squared. So x sine y squared.
Equals
Yeah, x sine y.
y is squared here?
Yeah.
Alright. Well, find dy dx is a good question. Yeah, so you have to do the product rule on each side, right? So on this side, first differentiate the y, leave this alone. Derivative of y is just y prime. Leave the sine x squared. Plus, now you leave the y and you differentiate the sine x squared, which is going to be 2x cosine x squared. Equals, same thing here, differentiate x, you just get 1, leave the sine y squared. Plus, you leave the x, differentiate the sine y squared, which is 2y cosine y squared times y prime, because that is differentiate with respect to y. And now I just, again, prove this. This is y prime times sine x squared minus 2xy cosine x squared. Here I have sine y squared squared minus 2xy plus x squared.
Professor, let's say you didn't put the 2x and y together, would it still be correct?
What do you mean?
Like you see on the answer, I wrote sine y squared in the top one. Sine y squared minus y cosine x squared. Yeah, cosine x squared and all that, and it was 2x. I didn't multiply.
You mean you put like times 2x?
Yeah.
Instead of putting, yeah, there's no difference. It looks weird, but that would be wrong.
Simply go to number 1, part B.
What was part 8? What was the function?
9x squared minus y squared equals 1.
And part A was to find dy dx.
Yeah.
So 18x minus 2y
It's
y
finding
prime.
implicit.
So y prime is equal to 18x
Divided by
divided by 2y.
negative.
Plug in the y.
So this would just be 9. Again?
Yeah.
Yeah, so that's the dy dx, and then,
Now finding that explicit.
oh, this is part B.
Yeah, he was asking for B.
So, right, but that was part A,
Yeah,
find y
yeah,
prime.
yeah.
Okay, so part B is to find y explicitly.
Explicitly, yeah.
Well, what you do is you solve for y first.
Yeah.
So you have x squared minus 1 equals y squared, which means your y would be equal to, it's actually plus or minus the square root, 9 squared minus 1. And it depends where you want to be. If you want to be on the plus side or the minus side. If they give you a specific point, you'll just go with the point that matches the sign that you would take. So now it's just a matter of dy dx equals, you differentiate this.
That's part C.
So this is plus or minus, this will add 9 times. So this is 9x over 9 squared minus 1 bracket. Which you might have known is 9x over y, right? Because your y is plus or minus this radical. Right? So it's actually the same. Is that it?
Yeah.
Here's a question for you. And you guys can pass it along.
That related to grade.
Huh?
this dx dy, do you just do the same but for the x's?
Yes, I want to emphasize that sometimes the prime can mean different things, which is why it's not a very good notation when you start getting to these multiple derivatives and implicit differentiation. And especially in Calc 3, you're going to be differentiating with respect to all different kinds of variables, so you have to really know what your prime means. Basically, what this notation means is you always consider this guy as an independent variable, right? The guy on the bottom, right? So basically the idea is whatever you're differentiating that guy, you don't have to do anything, but when you're differentiating any other variable, you have to attach the derivative to it, right? Because the chain rules apply. Right? And you can sort of think of implicit differentiation as you're constantly taking an account of what you're differentiating with respect to. So for example here, why is it that when I differentiate 9x squared, I don't have to do anything? Because you can sort of think of this as what you just did is you differentiated x with respect to x, right? You differentiated the x function with respect to x. That sort of cancels and you don't have to write it, right? So technically you're always saying, okay, I just took this derivative, I just took this derivative, I just took this derivative, and you're always saying with respect to what, right? So when you're doing it with respect to anything, you're always saying, I'm always taking the derivative of this with respect to that. And you keep going, and that's what the chain was telling you to do. But let's actually see this in action. And this is why in related rates, we had to be putting dx dt, dy dt, right? Both our variables, we have to be attaching derivatives to them. It's because the independent variable wasn't matching the variables we were differentiating. So if I wanted to do dx dy, how would that work out? 2xy, and this time you have to put it dx dy, or x prime, right? Because you just differentiated an x function, and their input variable is y. So that's the guy that's weird, right? That's the guy that really has a function packed into it that we don't know. Right? Plus, that's just x squared. Now you don't have to do anything when you differentiate the y because he's the independent variable. Plus, minus sine y equals what's this one?
Y negative 1 dx dy.
You move it up.
Yeah.
Okay, so you think of this as x, y to the minus 1, sure?
So just y negative 1 dx over dy. We just want derivative of x, so this is just 1. So it would be y negative 1 dx dy.
Right?
Dx dy and plus x
Minus x, y to minus 2, right? And this is a 5, not an s, so. Because it would be a totally different answer if it were an s. And, right, so now we want to solve for this guy. How do we do that? Well, isolate this as before. So here's dx and dy. 2xy minus y to the minus 1 equals, bring this over here, sine y minus x squared minus xy squared. And I can divide by minus 2 minus 2.
and negative sine y.
Are we okay now?
Yeah, positive sine y.
Right, so you have this. Now if I actually find dy dx, how do you do it?
dy dx.
Implicit differentiation.
Huh?
To do the regular way that you used to do the
Let's do
want
the
to
derivatives.
x.
Because there's something interesting I want you to notice here. So if we differentiate this with respect to y this time, right, dy dx, this I get 2x y plus x squared
dy dx
dy dx
minus sine y dy dx
minus sine y dy dx
x, y, negative 1.
Right, I'm going to think of this again as x, y to the minus 1, or you can do the quotient rule if you like the quotient rule, I don't really care. So you get y to the minus 1 plus, well now it'll be minus xy to the minus 2 dy dx, right? Now we want to isolate this guy. So here, what happened?
No.
Minus 2xy minus x squared. Sure that takes care of this. But no, I didn't do the x squared.
Wait. There's only one on top, negative 2xy.
So this is x squared plus minus sine y plus xy to the minus 2. Right? I brought this over and just factored it out. Over here I'm going to have y to the minus 1 minus 2xy. Is that okay?
1. Yeah. Oh, I missed that.
So dy dx would be
Skirts.
do you notice anything?
Yeah. Negative reciprocal?
Is it the negative reciprocal? Yeah.
Well, it's not just reciprocal.
Oh no, actually yeah, it is negative.
It's negative reciprocal. It is negative.
It's perpendicular.
In this case.
How is it negative reciprocal?
Because you flip it and then you take
No, but still denominator is different because I think it's multiplied by negative.
But multiply by minus 1 over minus 1, what do you get? 2xy minus y to minus 1, right?
Yeah.
Over, now the sign would be positive.
side y.
Sine y
Minus x squared.
minus x. Yeah.
Right? What do you notice?
Oh, now you see.
It's the reciprocal, it's not the negative
Yeah,
reciprocal.
that's like
This is actually equal to 1 over dx dy. Right? You
Oh,
see,
yeah.
the point I want to make here is the differentials. It's sort of weird. You can actually manipulate them like fractions. You can invert them, take reciprocals, and do all sorts of stuff. The Leibniz notation is actually pretty versatile. We won't take much advantage of it here, but in Calc 2, you're going to be taking advantage of this all the time. You're going to be able to like cancel the dy's and multiply this and flip them, and you can use them like fractions. Right? So that's just one thing I want you to know is something interesting. So if you went through all the trouble of finding dy dx, then to find the other one, you just flip it. You don't really have to go through the work again. Because you can think of they work sort of like fractions. You can, in a strange way, they're reciprocal to each other. Yeah. Other than that, I think we'll just move on. We're going to finish the related rates.
Professor, I have a quick question. On the quiz, it was like sine and then parentheses 1 and parentheses.
What?
But it was like sine, like just put sine and then parentheses 1.
Oh, sine?
Sine of 1.
Yeah. What about?
And like to find the derivative of that, you would like it would
It's
be
a constant.
cosine. So it would be all 0.
It's 0.
Alright, so right.
Yeah.
I was not too sure.
Yeah, sine of a constant is just a constant. The derivative is 0. All right, let's finish this guy and then get on. We already started number 4. We did the setup, so it should be. You have the handout.
Do you have any other classes? Daytime. The whole daytime. The whole day you wait.
Oh yeah.
Yeah, the first one is
Quarter to circle. There's only one class in the morning. That's
Alright, slow down, we're not time to get through this. Okay. See you guys there. The setup was the following: A and B started here, A started going south, B started going north. The trick was to sort of make this little right triangle thing, or we call the variable of the hypotenuse, which was the distance we wanted to find. We call that Z. Did I call this X?
Yeah.
And that Y? Right, so this whole thing here was X plus Y. This whole distance here was 80. Right. And so we figured out, so we read the problem, we wrote, what do we know? We know about the XDT. 10 divided by 2 is 20.
40 and 10, 20.
We actually want the ZDT when X is 20. X was 20 and Y was 40. Right. And we just solved that by going to our equation and solving for X and Y. So, well, no, we solved it by actually knowing the distance. We know it's moving 10 miles per hour for 2 hours, so it's covered 20 miles. This one's moving 20 miles per hour for 2 hours, that's 40 miles. The equation was by Pythagoras' theorem. We know that X plus Y all squared plus A squared plus Z squared. So that was our equation. That's 3 variables. We're differentiating with respect to t. Apply chain rule here. Multiply by derivative inside. X derivative, that is 1. And let's take the derivative x with respect to t. Plus derivative y is 1. And let's differentiate y with respect to t. Derivative 80 squared is 0. Derivative this is 2z. I just took the derivative of z with respect to t. And now we knew everything, so we're just going to plug them in. X was 20, y was 40, dx was 10, dy was 20, x was 2, z was, what was z? 100. Again, because it was a 3, 4, 5, z dt. So z. So we can cancel the 2's, and here we have just 60 times 30 over 100. So the zeros cancel. It's just 18. Any questions on that? All right, so the trickiest part here was actually coming up with a diagram. Some people might have seen 2 right triangles and then dealt with it separately and then added the rates at the end, but it could have worked that way. It just would have taken a lot longer. It's easier to just combine them into one big triangle. Let's talk about problem 5. So I chose this problem because it's has a very important concept into it, and that's similar triangle.
Oh.
Water tank has the shape of an inverted circular cone. There's just a cone. Base radius is 3. So you know the distance here is 3. Height is 9. It starts off filled with water. It's filled with water. Here's water in this thing. Okay, but the water is leaking out from the bottom. It's leaking at 2 meter cubed per minute. How is the radius of the remaining water decreasing when the radius is 1 meter, right? So of course, eventually the water is leaking, so eventually it's like here, right? So you can measure the radius there, right? It leaks down more, notice that the radius will be smaller, right? I want you to know what rate is this decreasing when I get to a point where R is 1. So that is the goal. Yeah. And man, there are always odd reasons on like that. Buying 50 cantaloupes. Right. So that's sort of the picture that's going on. By the way, the leaking, how can we quantify that? What is it? Volume. How do you know it's volume? Well, meter cubed. It has a cubed unit, right? So you can think of this leaking as decreasing volume. So what do we know? What do we want? The only thing we know is how the volume is changing, dV dt. Right?
Negative 2 and
minus 2. Why is it minus? Because it's decreasing. Remember, this is an important concept. So it's very important for you to, step 1, read the problem carefully, and you have to realize, oh, it's decreasing, meaning I have to put a negative sign. Otherwise, you'll get the problem wrong. Okay, so that's pretty much how we know how fast it's leaking. But what do we want? We want the R dt, how fast is the radius changing when R equals 1. Alright, so how are we going to do this?
we have the equation.
You know the equation? I gave it to you in this case. V equals pi 1/3 pi r squared h. Can you foresee a problem here?
We're good. Wait.
We can make this dv over dt because we know that dv dt.
Huh?
Should we get this in terms of one variable?
Too many variables. Why is it too many variables?
One too many.
Right? This is an R, this is an H. Means when I differentiate, I'm going to get a dr dt and a dh dt. Right? I don't know dx dt, I don't know dr dt. There are going to be two unknowns there, but it gets even worse. Yeah, well, I'm going to have two unknowns there.
We
Right?
can just find the volume first.
How would you find the volume? The only thing I know is the radius is 1.
You also have height.
Yeah. Okay, so how do I know what the height will be when the radius is 1?
Do we need a proportion here?
Right. This is where the whole concept of proportion will come in. That's what we're going to be using, right? All right, this is too many variables. In particular, it would be nice to get rid of the h. But how, right? Solving for h won't really help because then you're going to have the v still there, right? And you're going to have r in terms of h and v, and it's still a bad situation. The trick is, in this particular case, similar triangles. You guys know what similar triangles are and what the properties they have?
The same angle, but
Yeah, if it's proportional, you can sort of make the sides proportional, right? If it has all the same angles and all the sides will be proportional. The idea is you're going to slice the cylinder, right? Right? There's going to be some point where the radius is here, right? Now this is the maximum radius, that's 3. The height of the whole thing is 9, but the height of when I'm here, I don't know what it is, call it h. What you'll realize is that I can sort of extract this triangle. Where this is R, this is 3, this is H, and this is 9. See, this big right triangle here and this right triangle here are proportional, right? Because you just have one triangle and you cut it with a line that's parallel to one of the other sides. You obtain similar triangles by doing that, right? So what do we know about similar triangles? All sides are proportional. So if I know the base over height, well, I want to get rid of R. Let's put the height first. The height over the base of the small triangle will be equal to the height over the base of the big triangle, right? This is what similar triangles means. They're proportional in their side lengths, right? What's the height over the base of the small triangle? Well, the height is H, the base is R. So this is just H over R is going to be equal to the height over base of the big triangle. The height of the big triangle is 9. The base of the big triangle is 3. So it turns out that H and R are always proportional, and in fact, H is equal to 3R. Right? So knowing that, I can get rid of that H.
Did you take a drawing class?
Huh?
Did you take a drawing class?
Come on, I've been drawing this diagram my whole life. You see Calc 3, that's fun. That's some really nice drawings that are not in Calc 3. Okay, so now we know that V is equal to pi 1/3 pi r squared H. The thing is, H was a problem, too many variables. I don't know the HDT and any of that, so what I did, use similar triangles to actually replace H with its equivalent expression in R, and it was 3R. So this will cancel. It means I can actually write the volume of this particular cone as pi r cubed. Yeah. This is not true in general, it's just true for this one. The proportions just work out that way. Right? For a cone, a right circular cone where the height is 9 and the radius, base radius is 3, you can actually express the volume this way. And so now you just differentiate, that's step 5. 3 pi r squared, dRdt. And now I actually know everything, I can plug it in. dV dt was minus 2. 3 pi times r is 1. So it's decreasing at that rate. Okay, questions? So this is what I was trying to talk about in step 6. Sometimes I have to go back to the equation to solve for stuff. Sometimes you can use the geometry suggested by the diagram to eliminate one of the variables. This is one of the questions where you can do that, right? Use the geometry of the situation. You can come up with similar triangles, and using that, you can eliminate the H, get rid of the R, because you didn't know enough information about H. You didn't know what the height was. You didn't know how fast it was changing, right? There were too many variables, so you get rid of one. And if you can't solve for it from the original equation, because doing that, you'd still have all the variables there, right? So you go to the geometry and try to figure something out to get rid of it.
You know it's 550, right?
What? It's not 550.
You know it's 7
Oh,
Check the
that's
551.
No, your watch is fast. It's like 549 or something.
Can you do it? In that
Well, I could, but would you guys understand?
No. If you write it down,
Maybe I'll throw it on the quiz.
We'll finish up Monday.
What? No,
Monday?
Oh, by the way, the test is going to be a week after Tuesday. The second.
So it's like.
Do we have a midterm?
You're gonna be what?
It's not really a
Yeah,
midterm, it's
what
a second
date?
test.
Do we have a midterm?
No,